Hello, my name is Kyle Lajeski, and I'm an Area Vice President with EMC. And today I want to spend some time talking about converged infrastructures, specifically why there's so much hype and excitement around the market. I think you oftentimes have to start with understanding really where the CIO agenda or initiatives are. With the advent of companies like Uber, Nest, Amazon, and others who are taking traditional or historic industries and turning them upside down with a digital agenda or a digital transformation, I think many companies are looking to their products, services, and offerings and finding out new ways to leverage big data, mobile, next generation apps, and cloud to help transform the digital enterprise. While they do that, cost is a key focus and requirement, specifically around leveraging converged infrastructures, flash, and transformational or enterprise licensing agreements to drive down costs to then fund that digital strategy or transformation, all while managing the risk continuum, both the risk of their data and their brand, and really the risk of the vendors that they do business with, ensuring that there's a consolidated stack of highly viable vendors in the marketplace. Specific to Converge being a key enabler of driving this cost down, I oftentimes start with a basic analogy that contrasts how we do business historically in IT to something we all understand, which may be taking a vacation. In this case, I'll travel from the Mid-Atlantic to California by car. And really, as I set out on this vacation, my sole goal here is to get on vacation. That is the primary outcome of my objective. In order to do this, I really can do it two ways. I can build the car. And in building the car, I have to go through an engineering process of what the car needs to look like. I have to figure out my requirements. I have to design it. I have to then source all the different items from many different vendors. I have to manufacture all of those pieces myself in an assembly. Then I actually have to test the car. I have to figure out how I'll manage and report on the car and its capabilities like temperature and oil and gasoline. And then in the event that something happens, I need to support it and I need to be able to sustain it. Then while on vacation, I have a few other implications that occur. Or I can literally go to the dealership and I can buy a vehicle. There are many great car companies, General Motors and Ford being great American brands, that engineer, manufacture, manage, support, and sustain vehicles themselves, which creates a very direct and predictable outcome to how I'm going to get on vacation. And while on vacation, in the event that I built my car, I have a number of different items that I have to worry about that take me away from my initial outcome, which is really driving towards that vacation and getting there and enjoying my vacation. Whereas in a General Motors example, if I have an issue, I really just pull into any dealership and I resume my particular vacation. I liken this very much to how we manage IT today. We really have two choices. We can literally go through each level here and engineer a solution with compute, network, virtualization, storage, replication, and backup. After we get done doing the physical engineering, we have to do a lot of the logical engineering of compute layer, fiber and IP networks, HBAs and NICs, guest OSs and BIOS, RAIDs, LUNs and tiers and storage infrastructures, how I replicate data protection, etc. I then have element managers for each, whether it be vSphere or UCS manager, Fabric manager, or in EMC's world, Unisphere, and then I literally have a support contract that's discrete and specific to each one of those components. And then literally once I get all this running, when I go to sustain this environment, I have to understand all the interrelationships between every one of these elements. And then each one of these elements starts to cross between items. If we look at a lot of the challenges in IT and a lot of the Sev 1s, somewhere in the neighborhood of 70 to 80% of outages in Sev 1s are really caused by these arrows. It's the interdependencies between all these different layers, both physical and logical, and an organization's ability to keep up with all these interdependencies as an environment grows and expands. If you really think about it, this might just be one environment for one particular application, and as applications grow and scale, this becomes even more complex. There has to be a better way. And this is really where the converged infrastructure conversation comes in. This is analogous to the previous example where my goal was getting on vacation. Here, my goal or outcome is to run the application. I can build the car and all of its piece parts on the left, like I showed in the previous slide, or I can leverage the deployment of a converged infrastructure, much akin to buying the vehicle in its completed state. So let's talk a minute about what this is. This is really an engineered solution from end to end. We literally work with some of the best and brightest engineers in figuring out ratios and integration points and elements to engineer it. We then pre-rack, pre-stack, pre-cable, and manufacture the entire solution, including the logical configuration. From a management standpoint, we can understand and see this with a single unified element we call vision. We support it under a single contract, and we leverage a release compatibility matrix, which literally twice a year we go through hundreds of regression tests to better understand how these codes interact and then deploy them as a single code load for the entire block, which applies to the hypervisor all the way down through the backup and data protection and everything in between, eliminating the gaps at the seams and ultimately driving towards a more predictable outcome. We also start to look at how this transforms my people. On the left, you can see we're likely going to have a server, network, storage, and backup administrator. And then it's going to take me likely 6 months to engineer and manufacture this solution. And then I have to manage it, support it, and sustain it on my own. In the vBlock world, we leverage what we call a converged architect, have a full education and training roadmap to get us there. We call CAP, or the Cloud Acceleration Program. So we talk about some of the substantial impacts here, really being the people transformation of server and network storage admin into converged architect. That then it gives me the ability to reskill and retool a lot of those resources to focus on higher value tasks, for example, that digital transformation. We talk about the deployment being 6 months on the left and potentially, in most cases, 30 to 45 days on the right, due to how we do the engineering and the manufacturing. But really the long-term support, how I manage it, how I support it, and how I sustain it are the ongoing value props within this converged stack. So it's product in the elements, it's process and how it's engineered, manufactured, managed, supported, and sustained, and it's people in how we facilitate that transformation. And that really is the magic of converged. Don't take our word for it. There's been a ton of third-party work done here. As you can see on the left side of the screen, we have a number of VCE benefits that have been reported from customers. We also had IDC do a number of benchmark tests. And the thing that we are seeing consistently in this is a huge reduction in staff, resource, and labor costs, allowing us to refocus on those higher value, higher impact tasks, in this case a 4x reduction, which makes sense when you think about server, network, storage, and backup into a converged architect, and a huge improvement in availability. In one study, 83x. In a different IDC study, a 96% less metric in downtime. And this also drives to significantly reduced cost. All that being said, we can really get into some details on how these elements are engineered, piece by piece, element by element, eliminating your need to go through the engineering process. These manufacturing facilities are amazing. We literally take 300 individual components and 60 points of integration and nearly 30 code elements in the build and deliver this as an integrated product in less than 45 days. When we start to look at how this is managed, this is an unbelievable demo I'd encourage you to see in the Vision software on how we see and integrate these elements. The support is fantastic. It's not just a single phone number. We actually can take 90% of those calls and close them out without having to escalate the elements. So not one phone number, but one support number. And then when we get into that RCM, how we actually do the code level and sustain that code level, it's actually a patented process in itself. Here's another great customer example. In this case, we leverage flash technology in EMC's Extreme I/O on the back end, and we're seeing huge improvements: an 84% reduction in power and cooling, an 87% reduction in actual physical disk drives, huge savings in floor space, much lower response time, a much faster system overall. We're getting incredible deduplication in this case, 3.8 to 1 across the mixed workload with guaranteed inline all the time data services. And we're getting all this at a significantly lower ROI, in this case a 47% reduction in ROI, and you can see some of the metrics there below. Finally, we oftentimes have a challenge with how we get started, and this is a great starter kit. We've actually integrated all the elements here, server, network, storage, and hypervisor, and delivered this solution at a price point that's under $500K. Of course, these are customizable, and you can integrate and elevate these in any way you would like, but this is a great starting point to begin this transformation towards a converged stack and a converged architecture. So I really appreciate your time today. Hopefully this was eye-opening in how we leverage converged infrastructure. Thanks, and have a great day.